welcome back to my channel. So in this video I'm solving a difficult problem over here of the curl and divergence. I explained to you guys what is curl and divergence in the previous video, and I solved a simple example. If you want, the link to that video will be shown over here in the I button. You can check that out before if you want. Alright, so let's solve this problem. Find the curl and divergence of the function given below, and the function is x minus y cubed I hat plus e to the power of y z g hat and xy e to the power of 2y k hat. Alright, so we are finding for the curl, and like I explained you guys in my previous video for the curl, that you guys don't need to do the cross product of the gradient like this, the gradient cross product with f. This is a really long procedure and you don't need to do that. I've shown you guys a trick to do it, so let me just recall the trick that I showed you guys. Okay, so you need to write like P, Q and R, because your function here is is represented as P, the I component is P and the J component is Q and the K component is R. Okay, so you write P, Q, R, and then right in front of them you write X, Y, and Z. Since it's the X variable, X component, right? I hat simply means the X component, Y component, and Z component, right? So you just need to write X, Y, Z in front of them of what it represents, because P represents the X component, Q represents the Y, and R the Z component. Okay. Now, what you need to do, for the first one, you're going to write I hat, and I hat represents the X component, right? So you're going to cross out the X component, and then you're going to, you guys remember taking the determinant, right? Determinant is this times this, and then negative this times this. So you're gonna go in the opposite direction of a determinant. You won't go like this to this, you're gonna go from down to top. Instead of going from up to down, you're gonna go down to top. Okay, from bottom to top. So you're going to multiply this times this, which is R times Y, and then before you go in the other direction, you have to put a negative, and negative this times this. Negative QZ. Alright, now we are in the J direction. Okay, so you have to put a negative J. Always, it's gonna be always negative J. Okay, so let me remove this then. J direction means we are in the Y component, so we need to cross out the Y. And now let's do the same thing, working in the opposite direction of the determinant. So R times X, and then of course a negative before going in the other direction of the arrow, a negative, and then P times Z. First you have to do down to top and then negative, top to down, PZ. And now you are in the K direction, so positive K, so only J is negative, remember, the rest is positive. Okay, so now you're in the K direction. That means you are in the Z component, so you're going to cross out the Z and then do the same thing. So now we're working in, remember, in the bottom to top direction, so bottom to top, and then negative top to bottom. So Q times Z, Q times X, and then negative P times Y. And there you go, you guys have your curl equation right now. No need to perform this calculation. This is a lengthy calculation, you don't need to do this. You simply need to memorize this formula, and I know it's a big formula and it's hard to memorize this formula, so you can easily derive this formula using this trick. Alright, and yeah, you guys don't need to write the notes. I will provide the notes in the description below. Alright, so once we have the curl equation, now it's simply finding out these values and plugging it into this equation. So this R of Y simply means this R, right? So this is the R, like I said, this is P, I hat is P, J hat is Q, and K hat is R. So this is R of Y, which means the partial derivative of R with respect to Y, and here this means This means q of z means partial derivative of q with respect to z, and so on. This means the same thing. Okay, so let's calculate r of y first. R of y, let me use white. Okay, r of y. So first of all, we have r over here, so we are differentiating y only in here, and so we are differentiating only x. This means the other variables are treated. So we are differentiating with respect to y, which means all the other variables we treat as constant. So x and z are constant. Since it's a 3-variable function, we're differentiating with respect to y. So x and z are treated as constant. And here you are differentiating this one, and you guys need to know that this is a 2 function, right? There are 2 functions, so you cannot differentiate it directly. You need to use product rule. So this is one function and this is the other function. So x and y is a one function, and then e to the power of 2y is the other function. Okay, and I hope you guys remember the formula to finding the product rule. So for the product rule, we have an f is the first function, so x and y is the first function, and g, which is the second function, e to the 2y. And remember the formula. So the formula to find the product rule is, where do I write it? Okay, so I'm gonna write it over here. I'm gonna move this at the bottom, r, y, x, z constant. So I'm gonna remove this and write the formula over here. F prime times g plus g prime times f. This is the formula. So f prime means the derivative of this one, and g prime means the derivative of this one. So first finding the f prime. So f prime, taking the derivative of this and remembering that we are differentiating with respect to y. Okay, with respect to y, so we differentiate y only. X is a constant, stays over there. Derivative of y is simply 1. And now differentiating g with respect to y, of course. So e to the 2y, the derivative of e to the 2y is e to the 2y, and then times, this is a chain rule, right? So if you have, for example, e to the 2x, the derivative of this, how you're going to calculate it? So it's going to be the same thing first, e to the 2x, and then you're going to multiply it from the by the derivative of the inside function. So the inside function here is negative 2x, and what's the derivative of negative 2x? It's simply 2, right? So this is going to be answer to this one. So similarly, we're going to do over here. So first we're going to write the same thing over here, e to the negative 2y, and then the partial derivative of the inside function, and differentiating with respect to y, right? So what's the derivative of 2y? Simply 2. So it's going to be the same thing. 2 e to the 2y is g prime. Okay. Let me remove this. Okay. So now let's plug into the formula now for the product rule. So we have in here, so this is going to be f prime times g. So f prime times g plus g prime times f. Okay, if you want, you can simplify it a little bit. Sorry. X e to the 2y plus xy xy 2e to the 2y, and you guys see x e to the 2y it's in here, and x e to the 2y is in here as well, so you can factor it out. X e to the 2y, if you factor it out, so this is, here we're left with 1, and then here you're left with 2y. So this is the answer for r of y then. Okay, so now we have r of y over here. Next, what do we have next with r? With r, we can find r of x as well. Okay, so we need r of x. And here, r of x, we have xy e to the 2y. Let me just zoom out. It's easier for you to see that. So xy e to the 2y, so you're going to do the same thing over here, the product rule. But if you guys realize here, the y is constant over here, right? So So this whole thing is constant, and we're differentiating only x, and the derivative of x is going to be y. So the answer to this one is simply going to be y e to the 2y, since it's a constant, right? It's just like writing 2x, and 2x is a constant, and the derivative of x is simply 1, right? So what's the derivative then? So it's 2, right? So it's the same thing. So this whole thing is a constant. It's just going to stay over there, and this is a x, so the derivative of this is 1, right? So that's why it's this. If you want, you can apply the product rule over here, but you're gonna get the same answer. Okay, so now now we have r of y, r of x. We can go ahead and find q of z. Okay, let's find q of z over here. So this is q, right? We are differentiating z over here. So again, like I explained you guys before, how do we take the derivative of this a function like this? So first of all, you're going to write the same thing over here, and then multiply by the derivative of the inside function. And here we're differentiating z only. This is 1, and this is a constant, so it's going to stay over there. So then the answer is negative y e to the negative yz. Okay, next, what do we have with q? Then we have q of x. So let's write q of x over here. This is our q, and we're differentiating with respect to x, but here there's no x, only y and z are treated as constant over here. So that's right, the answer to this is simply 0. Okay. Okay, so we're done with q of x as well. Now we're only left with pz and py. Okay, so let me write it at the bottom over here. P of z. P of z. Okay, so here we're differentiating with respect to z, but there's no z over here, only x and y is constant over here, so pz is 0. Okay, and now finally we are left with p of y. Now we are here differentiating y, so wait, I'm gonna write it above so you guys can see it better. Py. Okay, so we're going to bring the 3 down, like we take the derivative of this, right? So we're going to bring the 3 down and then x squared. So this is the same thing in here. Okay, but it's a chain rule, so then you're going to multiply by the inside function as well. Okay, first of all, you're bringing the t down and writing this exactly the same way, and then subtracting 1 from the exponent, and now multiplying by the inside function, since it's a chain rule, but multiplying by the derivative of the inside function. And remember, we are differentiating with respect to y. This is -1, and this is a constant, so it's 0. So multiplying with -1 then. So this is going to become -3 x to the power of -y squared. Okay. Okay, now we have everything needed. Now it's simply to plug in into this formula to finally find the curl of the function. Okay, I hope it's not so small for you guys and you're able to see it clearly. Okay, by the way, the notes are in the description below, so if it's not clear, you can check the notes out. Okay, so the curl of the function is going to be r of y is in here, y e to the power of 2y, and then q of z. Q of z, it's in here, negative, and you guys see it's already a negative over here, so then negative y e to the power of yz, and then all this in I hat. Okay, and this negative, so you can make it into a positive. Okay, next we have -g hat, r of x. What is r of x? Where did I put r of x? In here. Okay, wait. This was r of x. This is r of y. Oops, sorry, I made a mistake. I'm gonna rewrite it. R of y is in here. So x e to the power of 2y times 1 plus 2y and then negative q of z. So it's in here, like I said, negative, negative, that's a positive. So y e to the power of negative yz, and then negative j hat r of x, y e to the power of 2y negative pz. Where's pz now? That's 0. Simply use it, so you don't need to write it. Okay. Next we have positive k, and then that is q of x, that's 0. So again, you don't need to write it, but just so you don't forget the negative, I'm gonna write it for now, and then you can remove it later. And then we have py. Where are you, py? It's in here. And then again the negative, negative, and negative, negative 3x minus y squared, and this negative, negative are gonna become a positive then. Okay, and this is the final answer for the curl of the function. And yeah, you can remove this negative over here. Alright, so now let's move on to the divergence of f. Here it says curl and divergence. We just calculated for a curl. Now let's find for divergence. Okay, and for the divergence of f, like I explained you guys in my previous video, that for the divergence of f, you have to dot product the gradient with the f function. And the f function is in here, the p, q, and r one, right? I wrote at the top, the p, q, r. Here, for the curl, you have to cross product it, and here you have to dot product. Okay, so the gradient, you guys remember, it's nothing but simply the partial derivative with respect to x, I hat, and partial derivative of y with respect to j hat, and then partial derivative with respect to z, k hat. And then dot product it with the function p, q, and r. So p I hat, q j hat, r k hat. Now I hope you guys remember doing the dot product. The dot product is simply I hat times I hat, and the I component times the I component, and z component times the z, and k component times the k. So this times this, so this is gonna be partial derivative of p with respect to z, and then partial derivative of q with respect to y. And yeah, the I and j and k hat simply gonna cancel out. There's no I, j, k when you do the dot product, since it's gonna be a scalar product. Okay, this is a curl of f is a vector, but this is a divergence is a scalar. Okay, next we have r, z. Partial derivative of r with respect to z. For simplicity, you can write it at p of x, q of y, r of z, and this is the formula for divergence of f. Okay, if you want, you can memorize it, or else you can just derive it like this. It's not so hard to derive it, right? Okay, so next p of x. So next we have to find the p of x. So the partial derivative of p with respect to x. So let's see if we already calculated for it. So we have found the p. Where did I write p? Okay, so p of z and p of y, but we didn't calculate for p of x, so we need to do it right now. So p of x. Okay. If you want, I can simply write it over here. So p of x is going to be equal to, so where's the function? So let me zoom in a little bit. Okay, or I'm just gonna write it over here, so I don't need to zoom in again and again. X minus y q. Okay, this is my p, and we're differentiating with respect to x. So here, like I explained before, moving the 3 down, subtracting 1 from it, and multiplying by the partial derivative of the inside function. Okay, this is going to be 1, this is going to be 1, and this is going to be 0. Okay, so this is simply x minus y squared. Okay, next we have the formula says we need to find q of y and r of z. So q of y is right over here that I'm calculating for divergence over here. Q of y and r of z. Okay, so removing this, we have q of y. Q we have e to the power of negative q y z. Okay, so we are differentiating y over here. So like I explained before, we are going to write the same thing over here. E to the power of negative 2yz, and multiply by the inside function, the derivative of the inside function. This is going to be 1 and this is a constant, so negative z. So this leads to negative z e to the power of negative yz. Okay, next we have z. For simplicity, you can write it as p of x, q of y, r of z, and this is the formula for divergence of f. Okay, if you want, you can memorize it, or else you can just derive it like this. It's not so hard to derive it, right? Okay, so next, p of x. So next we have to find the p of x. So the partial derivative of p with respect to x. So let's see if we already calculated for it. So we have found the p. Where did I write p? Okay, so p of z and p of y, but we didn't calculate for p of x, so we need to do it right now. So p of x. Okay. If you want, I can simply write it over here. So p of x is going to be equal to, so where's the function? So let me zoom in a little bit. Okay, or I'm just gonna write it over here so I don't need to zoom in again and again. X minus y cube. Okay, this is my p, and we're differentiating with respect to x. So here, like I explained before, moving the 3 down, subtracting 1 from it, and multiplying by the partial derivative of the inside function. Okay, this is going to be 1, this is going to be 1, and this is going to be 0. Okay, so this is simply x minus y squared. Okay, next we have the formula says we need to find q of y and r of z. So q of y is right over here that I'm calculating for divergence over here. Q of y and r of z. Okay, so removing this, we have q of y. Q we have e to the power of negative q y z. Okay, so we are differentiating y over here. So like I explained before, we are going to write the same thing over here. E to the power of negative 2yz, and multiply by the inside function, the derivative of the inside function. This is going to be 1 and this is a constant, so negative z. So this leads to negative z e to the power of negative yz. Okay, next we have शुक्र नहीं बुलानी पड़ी वो कंटिन्यू
अभी अपनी स्पेसिफिक हो गई.
So here we are lastly finding the r of z over here, and r is over here. We are differentiating z, there is no z in here, so this is simply 0. And we have what we all needed. So for divergence of f, like the formula said, we needed p of x plus q of y plus r of z. Okay, so we're going to put it all together in here then. So you have 3x minus y squared plus, oops, sorry, that's a negative over here, negative z e to the power of negative yz and 0, so you don't need to write it, and this is the answer for the divergence of f. Thanks for watching. Please subscribe and comment.